What if an electron had enough energy to escape a material, but still couldn't find the exit? That's the quantum door mystery, and researchers at TU Wien just showed why electrons sometimes stay trapped, even when the numbers say they should fly free. Here's the idea. We usually think, give an electron more than the work function, and it can leave the surface into vacuum. But in layered materials, think stacked graphene graphite, that simple rule breaks. The team at TU Wien discovered electrons don't just need energy. They need the right doorway quantum state at the surface. No doorway, no escape. In their experiments and calculations, they looked at electrons moving through solids with layers. When light or voltage pushes electrons to higher energy, you might expect strong electron emission. Instead, they watched electrons pile up and bounce around inside, as if the building had exits on the map but no doors in the walls. The key difference? Coupling to specific doorway states. So what are doorway states? Think of them as surface-localized quantum states that overlap with two worlds at once. The electron states inside the solid, and the free electron states in the vacuum. They are the bridge. If your electron's energy, momentum, and symmetry match a doorway state, it can couple out and emit. If not, it reflects, even though it has enough energy. Inside a crystal, electrons carry momentum not just parallel to the surface, but also perpendicular to it. The surface and the vacuum enforce strict matching conditions. Selection rules. A valid doorway state must line up those quantum numbers and provide overlap with the outgoing wave in vacuum. In layered materials, the band structure creates pockets where the bulk supports motion, but the surface doesn't offer a compatible doorway. Result: electrons search, fail to couple, and stay trapped. Here's a handy picture. Imagine a frog inside a maze with a perfect jump to clear the wall. Energy's not the problem, but the only way out is a narrow door the frog must hit exactly. Miss the door by an inch? The frog slams the wall and falls back. In quantum terms, the overlap with the doorway state is near zero. So and see, bidawi sidgao. So and zero, so we're seen. Emission is suppressed. Why does this matter? First, it updates a textbook assumption. Energy alone doesn't guarantee electron emission. You also need the right doorway states at the surface. Second, it gives us a design rule for technology. If we engineer surfaces, by choosing specific layered materials, tuning stacking, adding ultra-thin coatings, shaping the local electric field, selecting photon energies, we can open or close doors. That means better photocathodes with higher brightness and lower noise, smarter electron sources for microscopes and accelerators, more efficient sensors where every emitted electron counts, and new routes in quantum devices where controlling which states couple to vacuum lets us manage loss, heat, and decoherence. The takeaway: doorway states, quantum energy levels, and momentum matching decide who escapes.